Space is vast, mysterious, and ever-changing. As we look to the future, there are incredible events and phenomena that will unfold far beyond our lifetimes. Things that will shape the fate of the Earth, the Sun, and the entire universe. From the eventual end of our Sun's life to the possible return of a lush Antarctica, the cosmos is full of mind-blowing events that span across eons. This video explores these unimaginable occurrences, offering a glimpse into what might happen millions, even billions of years from now, and what humans can expect to witness as the universe continues to evolve. Let's jump in. The Sun, as the central star of our solar system, provides the light and warmth that make life possible on Earth. But like all stars, its life is finite. In about 5 billion years, it will exhaust its hydrogen fuel in its core, leading to a dramatic transformation. The Sun will begin to expand into a red giant, swelling to possibly engulf the inner planets, including Mercury, Venus, and potentially Earth. While we may not be around to see it, the Earth will likely become uninhabitable as the Sun grows. As it sheds its outer layers, it will create a brilliant planetary nebula, a glowing shell of ionized gas. The core of the Sun will then collapse into a dense white dwarf, a tiny, hot remnant that no longer generates energy through fusion. Over billions of years, this white dwarf will gradually cool and fade, losing its shine. By this time, the solar system will look vastly different, with the planets no longer in the same state. This process is inevitable, and while life on Earth will no longer be sustainable, this event will mark the end of an era for our star and the beginning of an entirely new cosmic phase. Launched in 1977, Voyager 1 has been traveling through space for over 4 decades. It's the farthest human-made object from Earth, now over 14 billion miles away. Voyager 1's primary mission was to explore the outer planets, but its journey continues well beyond that. In the next 40,000 years, it will officially leave the solar system and enter interstellar space, an unprecedented milestone in human space exploration. However, this doesn't mean Voyager will be sending back data forever. As its power supply diminishes, it will eventually be unable to transmit signals, likely within the next few years. But the spacecraft's journey will continue regardless of whether we hear from it. Traveling at a speed of about 38,000 miles per hour, it will continue to drift through space, carrying the most distant message of humanity. The golden record aboard Voyager 1, containing sounds and images representing life on Earth, will be its message to any potential extraterrestrial civilization that might encounter it in the distant future. Even though it will never receive a reply in our lifetimes, Voyager 1 is humanity's most enduring emissary, crossing the boundaries of our solar system into the void of interstellar space. Dark matter and dark energy are among the greatest mysteries of modern science. Although invisible, dark matter accounts for roughly 27% of the mass in the universe. We can't see dark matter directly, but we know it exists because of its gravitational effects on visible matter. It plays a critical role in the structure of galaxies and the larger cosmos, but we still don't fully understand its composition or how it behaves. On the other hand, dark energy makes up approximately 68% of the universe, and it is thought to be responsible for the accelerated expansion of space. While dark matter and dark energy are invisible, their presence can be inferred through their influence on galaxies and cosmic expansion. Current research is focused on better understanding these phenomena, but despite significant advances, much remains a mystery. Many scientific missions, including the European Space Agency's Euclid mission and NASA's upcoming James Webb Space Telescope, are designed to investigate dark matter and dark energy in more detail. As we develop more sophisticated instruments and technologies, we may finally uncover the true nature of these elusive forces. The discovery of dark matter and dark energy could change our entire understanding of the universe's structure, its origins, and its ultimate fate. The Great Attractor is one of the most enigmatic phenomena in cosmology. This massive gravitational anomaly is located in the direction of the Centaurus and Hydra constellations, and exerts a powerful gravitational pull on our galaxy, the Milky Way, and many others in the Laniakea supercluster. The Great Attractor's precise nature has eluded scientists for decades, as it lies behind the dense plane of the Milky Way, making it difficult to observe directly. The gravitational effects of the Great Attractor are clear, however, as it pulls galaxies toward it at speeds of up to 2 million miles per hour. The mystery deepens because we still don't know what exactly is causing this massive force. Some theories suggest that the Great Attractor is a supermassive black hole at the center of a massive galaxy cluster, or perhaps a vast concentration of dark matter. Whatever it is, understanding the Great Attractor could provide crucial insights into the large-scale structure of the universe and the forces that govern it. As technology advances, astronomers will continue to search for a more direct observation of this cosmic mystery, which may soon unlock one of the most fascinating puzzles in astrophysics. Zombie stars are a peculiar phenomenon that could revolutionize our understanding of stellar life cycles. A zombie star is a star that has died but is revived due to a process called accretion. In a binary star system, when one star becomes a white dwarf, it can siphon material from its companion star, sometimes reigniting nuclear fusion. This allows the star to shine again, even though its internal fusion processes had ceased. These stars are often referred to as undead because they appear to be alive again, despite having gone through the death stages of a typical star. Scientists believe that such zombie stars could be more common than we thought, especially in the dense environments of star clusters where stellar interactions are frequent. The discovery of zombie stars could reveal new insights into the dynamics of binary star systems and how some stars manage to cheat death. Though this concept has been theorized for years, it's only recently that astronomers have begun to observe these phenomena. As more of these unusual stars are discovered, they could provide valuable clues about stellar evolution, the forces at play in binary systems, and the ultimate fate of stars that seem to defy the conventional understanding of life and death in the cosmos. Pluto's orbit is anything but stable. Over the next hundreds of millions of years, the gravitational influences of nearby Neptune and other planets will cause Pluto's orbit to shift. Currently, Pluto has an elliptical orbit that sometimes brings it closer to the Sun than Neptune, but a resonant orbit ensures that the two never collide. However, over long periods of time, Pluto's orbit will become even more elongated, and the tug of Neptune will have a greater effect, potentially causing it to change its trajectory dramatically. Although Pluto will not collide with Neptune, it is possible that Pluto's orbit could be disrupted, causing it to exit the solar system entirely. Such a dramatic event would mark the end of Pluto's long relationship with the Sun, but by that time, the solar system's dynamics would have likely shifted in other ways. Pluto's fate is a reminder that even the most distant objects in the solar system are subject to cosmic forces that can radically change their positions and paths over eons. Understanding the future orbits of bodies like Pluto will help astronomers predict the long-term behavior of the solar system and the stability of planetary orbits. The Great Collapse, or Big Crunch, is one of the possible futures for the universe, though it is still highly speculative. According to current models of cosmic expansion, the universe is accelerating, driven by the mysterious force of dark energy. However, if dark energy were to decrease or reverse in the future, gravity could eventually overcome the expansion. The universe could begin to contract, drawing galaxies, stars, and planets closer together. Eventually, all matter would collapse into a singularity, a point of infinite density and heat. While this scenario is not universally accepted, some models suggest that the expansion of the universe will continue indefinitely. The Great Collapse remains a fascinating possibility. If this happens, it would mark the end of the universe as we know it, but could also signify the beginning of a new cycle. Some theorists propose that the Big Crunch could lead to another Big Bang, creating a new universe from the ashes of the old one. The concept of a cyclic universe challenges our understanding of time and existence, and future discoveries could shed light on whether the Great Collapse is a real possibility or a fantastical idea. While the Earth has warmed significantly in recent history due to human activity, the planet's natural climate cycles suggest that the next ice age is inevitable. Ice ages are driven by long-term variations in Earth's orbit and axial tilt, known as Milankovitch cycles. These cycles affect the amount of sunlight reaching the planet, particularly in the northern hemisphere, which is key to triggering the onset of an ice age. The last ice age ended roughly 11,700 years ago, and Earth is currently in an interglacial period. But the cooling period that will eventually bring about the next ice age is likely to begin in tens of thousands of years. While human influence may delay the onset of the next ice age, it's unlikely to prevent it. When it comes, ice sheets will once again cover much of Europe, North America, and Asia, drastically altering the planet's climate and ecosystems. The effects of an ice age will reshape the landscape, force species to adapt or die out, and create new challenges for any life that remains. Studying past ice ages provides us with a glimpse of what's to come, helping scientists predict the future climate of Earth and the challenges it will face. Antarctica, as we know it today, is a frozen, inhospitable land of ice and snow. However, millions of years ago, it was a lush, green continent with a mild climate. Scientists have uncovered evidence of ancient forests and diverse ecosystems in Antarctica, suggesting that the continent was once home to a thriving array of plant and animal life. But as Earth's climate shifted, Antarctica drifted toward the South Pole, and the gradual cooling of the planet turned it into the icy wasteland we see today. So, will Antarctica ever return to its greener past? The answer lies in the slow, gradual movements of Earth's tectonic plates. Over millions of years, Antarctica could move closer to the equator, where it would experience warmer temperatures and possibly regain some of the conditions necessary for plant life. Additionally, as the climate continues to change, it's possible that Antarctica could begin to thaw, especially if global warming accelerates. If this happens, we could see the return of vegetation, with forests and grasslands sprouting once more across the continent. While this is a distant possibility, it's a reminder that Earth's climate has always been in flux, and Antarctica's future could be dramatically different from its present state. Just as the past climate of Antarctica was radically different, its future could once again be full of life in ways we can't yet fully imagine. In 1974, humanity sent a message into the cosmos that may take thousands of years to reach its intended destination. The Arecibo message, broadcast from the Arecibo Observatory in Puerto Rico, was a binary-coded message aimed at the star cluster Messier 13, about 25,000 light-years away. The message, which contained basic information about humanity, our solar system, and even our DNA, was sent as a demonstration of human technological capabilities. The Arecibo message, while simple by today's standards, was meant to represent the essence of human civilization. However, the time it will take for this message to reach its destination means that we will never see a response in our lifetimes. The message is expected to take 25,000 years to reach Messier 13, and if extraterrestrial life exists there, we might not hear back for another 25,000 years. This incredibly long time frame makes the Arecibo message a poignant reminder of the vastness of space and time. It also serves as humanity's first interstellar communication, a message sent into the unknown. As we continue to search for extraterrestrial intelligence, the Arecibo message will likely remain one of the most significant and enduring symbols of our desire to reach out to the cosmos. It represents both our technological prowess and our curiosity about the universe. If you enjoyed this journey into the far reaches of time and space, be sure to like, subscribe, and hit that notification bell, so you never miss another deep dive into the wonders of the cosmos. Until next time, stay curious and keep looking up.